Energy is the prime mover of economic growth and is vital for the sustenance of the modern economy. Future economic growth depends upon the long-term availability of the energy resources which are affordable, accessible and environmental friendly. Industrialization contributes to the growth of economy and requires energy. Consumption of energy and industrialization, they go together. If the economy has to grow, then energy consumption will also grow. The growth of economy depends upon the growth of infrastructure, and the infrastructure demands the consumption of energy. If I give you the data, for example, the major energy intensive industries in around 2005 required energy of the order of 68% of the total energy consumption. That means of the total energy consumption, 68% was utilized for the growth of energy intensive industries. Now with that I mean, for example, the chemicals, the sector which produces chemicals, for example cement and all others, it has consumed around 29% of the total energy. Iron and steel sector has consumed around 20% of energy. Now steel and cement are the two major infrastructure materials. Non-metallic minerals, have consumed around 10% of the total energy. Non-ferrous metals around 3% energy, and paper and pulp around 6% of energy, though these data correspond to 2005, but similar trend of energy consumption is also there in the subsequent years. India has set up around 8 to 9% economic growth in the years to come. With this high economic rate of growth, the demands on infrastructure material like cement, steel, non-ferrous metals is bound to grow. In an estimate, India would be needing around 600 million tons of cement by the end of 2030 and around 300 million tons of steel by the year 2030. So this suggests that industrialization, growth of economy and energy consumption are interrelated. It is in this perspective, let us see what are the energy resources available, because I have already said the long term sustenance of the economy will depend upon the availability of energy resources which are affordable, remember, which are accessible, and on the top of it they should be environmental friendly. So as such, energy resources. Now ultimate energy resource is the sun. It is the solar power that gives energy to the mankind. Now, part of this energy is stored below the earth crust and part is available above the earth crust. So, as such, I am going to divide energy resources in two parts. One, that is the primary energy resources, and second is the secondary energy resources. Primary you can also call natural resources. They are the natural resources, whereas secondary they are synthetically manufactured as per the demand of the industry. Now, let us take first of all the primary resources. Now, under the primary resources we can further subdivide. One is the non-renewable energy resource, and another is the renewable energy resource. Renewable energy resources. The non-renewable means it takes several millions of years to form a non-renewable source. It is in this perspective we have non-renewable and renewable. The renewable energy resources are available to us every time. Non-renewable energy resources, in fact, they are fossil fuels. They are fossil fuels, and renewable energy resources, they are generated from natural resources, The renewable means they are constantly renewable, they never exhaust as long as the solar power is. But the non-renewable energy sources, since it takes several millions of years to form and they form below the earth crust, it is in this time scale the fossil fuels are termed as a non-renewable energy resource vis-a-vis the renewable energy resources. Now, among these fossil fuels, they are in fact plant origin. Fossil fuels, they are plant origin. And among these fossil fuels, one have again three different type of fuel. One, as all of you know, is the coal, second is the petroleum, and third is the natural gas. Among the renewable energy resources, I think all of you know the most important one is the solar power. Second is the geothermal. Third is the wind. Fourth, biomass. Then we have hydrothermal. Now, let us take first of all little bit how these non-renewable energy resources are formed. So, let us take little bit of it. As I said, the non-renewable resources are from plant origin. There are special type of plants that give petroleum, natural gas or coal. Coal formation, it consists of two stages. First stage is the biochemical stage. In the biochemical stage, the plant materials decays under the earth crust and they are attacked by the bacteria under moist condition. After this, there are several earth movement below the earth crust, several geological forces are also acting under the earth crust. So, the deposit which has been there at a particular time, it gets further buried into the earth crust or below the earth crust, and as a result of temperature and pressure, the process of coal formation begins. So, the second stage is called metamorphism. Metamorphism, or it is also called dynamochemical stage. Now, in this stage what happens? There is a effect of pressure. Because of the depth, because of the movement below the earth crust, the deposit which has been occurred earlier gets buried further, and as a result of which the effect of pressure begins as you go down the depth. Again, there is a tectonic pressure. There is a tectonic pressure which is caused by movement of the earth, and as a result the deposit may be buried into the some type of rocks below the earth crust. Then there comes effect of temperature. Then there comes effect of temperature, because there is a rise in 3 to 5 degrees Celsius for every 100 meter increase in depth. So, what happens in this stage? And this is the most important stage for the formation of the coal deposit. In substance, there is the effect of temperature and very high pressure, and on account of which several physico-chemical reactions take place during the life of formation of the coal. So, certain chemical reactions which occur in this stage, I will just put it over here, certain chemical reactions which occur in the dynamochemical stage they are, for example, dehydration, that is removal of water. Then another is decarboxylation, then third dehydrogenation, and on account of these three chemical reactions which are occurring because of the very large increase in pressure and temperature, there results in the removal of these reactions, results in removal of H2O, carbon dioxide, CH4 and H2S. So, on account of these physico-chemical reaction or dynamo-chemical reaction, the formation of coal occurs, and in fact the coal, it consists of organic mass because it is from the plant origin, organic mass, and this organic mass is a complex mixture of mixture of organic compounds of carbon, hydrogen, nitrogen, sulfur and oxygen. So, coal is a very complex mixture of all these things. Then also coal contains inorganic substances, inorganic substances like water and mineral, and mineral matter. So, as a result of these physico-chemical reactions, which are a function of depth, that is the pressure and temperature, the coal formation occurs to several stages. So, the stages of coal formation are: start with the wood is the first stage, then followed by pit. I am writing in the increasing order of the life of formation. That means, if you stop the process at this after wood, then you will get a pit. Then further depth you get lignite, then followed by bituminous, which is followed by anthracite, and then ultimately it goes to graphite. So, this in the orders wood to pit to lignite, bituminous, anthracite and graphite, they shows the ages of the coal. That means, the first stage of the formation is the pit, the further time it converts to lignite, then to bituminous coal and ultimately to anthracite and finally to the graphite. So, as a result of physico-chemical changes, the physical appearance change, the physical appearance, for example, color, strength and then density and structure. From the point of view of the user, the chemical changes are important. Chemical changes are important from the point of view of the user. Now, these chemical changes are, for example, oxygen content on dry ash free basis, it decreases, say from 40% for wood to 30% for pit and 20% for lignite, 5% for bituminous coal, and 2% for anthracite. So, you see that the progressive action of the pressure and temperature brings the oxygen down the value to the around 2% for anthracite. As a result of this, the volatile matter decreases from about 70% for wood to less than 5% for anthracite. So, decrease in oxygen and volatile matter content, it increases the available carbon from about 30% for wood and pit to almost 100% for anthracite. Based on the extent of qualification, one can say lignite is higher in rank, than pit, and anthracite is higher in rank than bituminous coal, Now, similarly, the petroleum is also formed under the earth crust by a special type of plants, and these plants are gelatinous in nature. Again, in the near sea coast, such type of plants are there, and with the same process of as I have described for coal buried under the earth crust, and over the time period of millions of years, the deposits of petroleum are formed below the earth crust. So, the liquid fuel oil is derived from crude petroleum. You know, liquid fuel oil is not a natural resource, it is obtained from petroleum. Petroleum is a natural resource, and petroleum comes from, in Greek, petra means rock and oleum means oil, that is, it is deposited below the earth's crust, below the rock, and when you drill the rock, then the petroleum is available for the users. Petroleum, it also contains elements, this is important for the user's point of view, elements like carbon, hydrogen, nitrogen, oxygen and sulfur. Now, from crude petroleum, several type of products are obtained. One is gasoline, then you have lubricating oil, then we have fuel oil, and so on. Several products can be obtained from this. Now, this is the non-renewable energy resources, also natural gas, it occurs along with the petroleum. Now, about this renewable energy resources, one is the geothermal, as I have said. Geothermal, that is energy obtained by tapping the heat of the earth below its surface. That means, we have hot underground water or steam is used to produce electricity because of the solar power which partly absorbed by the earth, and there are the hot water there, and this hot water is used for the generation of electricity. The geothermal plants, they can be there only where the hot water is available below the earth crust. Then another important source is the biomass, that is the biomass energy, and this consists of, say, for example, one is the biogas, which is produced from current waste streams such as paper and sugar production, animal waste and so on. So, in biogas, CH4 is the main product. Then we have biofuel like biodiesel, ethanol, they are derived again from plants. Then we have solid biomass, Then we have solid biomass, wood fuel, biogenic portion of municipal waste and certain plants. So, this is a biomass is a very important source of renewable energy that I will come little late. Another is the hydrothermal, energy. Now, hydrothermal energy in the water in the form of kinetic energy, temperature difference, and as such we have say hydrothermal power stations for conversion of kinetic energy of water into the electrical energy. Then we have solar energy, energy collected from sunlight. It can be used in many ways. For example, generation of electricity using photovoltaic cells, then generation of electricity using concentrating solar power, but the photovoltaic cells have a very low efficiency factor. Another source of energy is wind power. Now, wherever this wind power is available, this can be used for production of electricity. Now, what I wanted to say from here, I wanted to give you a picture of energy resources which are available to the mankind. Now, let us see what under the Indian conditions. Now, India, it ranks 6th in the world in terms of total energy consumption and needs to accelerate the development of energy sector in order to sustain 8 to 9% growth in the country, because energy, infrastructure and growth, they are interrelated. India, though rich in coal and abundantly endowed with the renewable energy, it has a very small hydrocarbon reserves of the order of 0.4% of the total world reserves. With the hydrocarbon reserves, I mean the fossil fuel reserves. For your information, India is a net importer of energy. More than 25% of the primary energy needs being met through imports in the form of crude oil and natural gas. So, this is an important point to note. When we relate our economic growth with the energy, we are also based on the import of the energy resources. As regards the energy production, now when we come down to the energy production sector, coal and oil, they account for 54% and 34% respectively. With the natural gas around 6%, India's total energy production is contributed by fossil fuel to the extent of 90%. Now, rest, say hydro, it contributes around 6%, nuclear around 1%, and that contributing to the rest wind or geothermal and so on. So, what is meant over here? That India is a very large consumer of the fossil fuel energy resources. Not only in India, around the world, 80 to 90% of the energy is being produced by primary energy resources, that is coal, oil and natural gas. Now, industrial sector in India, it consumes around 5.2% of energy. Another important point to note, when we relate energy with the economy, then it is also has a relation with the standard of living, and the standard of living, it can be measured or it is measured in terms of energy consumption per man. Now, consumption of primary energy in India is 530 kg of oil equivalent per person. Remember, 530 kg of oil equivalent per person, it was in 2004. compared to 1240 kg oil equivalent per person in China and the world average of 1770 kg of oil equivalent per person. So, what we see from here, the standard of living, growth in economy is highly related with the energy consumption. So, in terms of energy consumption, we are at least 3 to 4 times lower than the world average. So, what I wanted to convey to you is that the primary energy consumption per person, if it is an indicator of the economic growth, it will grow. Energy consumption has to grow because economy has to grow, because economy is an index of countries' prosperity. Now, when this is the picture, say 90% of the energy is derived from the fossil fuel. We are also convinced if the economy has to grow, if the country has to prosper, then energy consumption must increase. The question is how that can be met. In another way, I pose a question over here, are there certain issues related to fossil fuel? Why there is so much hue and cry that the world is using 80 to 90% of fossil fuel for the production of energy. India is also more than 90% using fossil fuel for the production of energy. Why there is so much hue and cry, and why we are crying that, well, what is the problem, what are the issues related to the use of fossil fuel as the energy resource? Because it is all at the moment the contribution from the renewable energy sources is very, very less because of the economical considerations. In the years to come, the fossil fuel will remain a dominant source of energy not only in India but around the world. Let us see what are the issues. Issue number 1, first of all, fossil fuel contains potential energy. Fossil fuel, it contains potential energy. What does it mean? You take a kg of coal, put it before you, it has energy but you can't use it. So, the potential energy of the fuel is obtained by combustion in terms of sensible heat of products of combustion. So, the potential energy of fuel, is converted to sensible heat in products of combustion, converted to sensible heat in POC, that is on combustion. Now, this heat transfer occurs between the source, which is the products of combustion, and the sink, which gives you the required amount of energy. After taking the required amount of energy, the source, it exits the system after imparting its energy. So, that means the potential energy of the fossil fuel is available by combustion and the products of combustion are discharged into the atmosphere. What does it mean? So, depending on the temperature of the sink, the products of combustion, they are discharged into the atmosphere. So, if higher is the temperature of the sink, higher amount of energy will be carried away by the products of combustion. Could you understand the issue? Here it calls for recovery, recirculation and reuse of the heat which is being discharged with the products of combustion. Issue number 1. Number 1 issue is that The potential energy of the fuel is obtained by combustion, and the products of combustion are discharged into the atmosphere, and depending on the temperature of the sink, the products of combustion will carry the large amount of heat. So, unless the concept of recovery, reuse and recirculation are not activated, the energy from the fossil fuel or a large portion of the energy of the fossil fuel will go to waste. Number 2 issue, fossil fuel, they are all carbonaceous fuels. If I combust 10 kg of carbon, then 10 kg of carbon will be in the output. So, that means the carbon emissions is one of the important issue. Carbon emissions as CO2 or CO, and emissions in general, for example, NOx, SO2 and SO3. What is this issue over here? Now, I give you an example. Nature has its own carbon cycle. If for the time moment we think that we are not using any fossil fuel reserve from the earth crust, then whatever carbon which is emitted by the biological activity of the human beings on the earth will be absorbed by the plant. Say CO2 again we use. So, there is a carbon net carbon recycling is 0. What we are doing by using the carbonaceous fuel from the earth crust? We are bringing extra amount of carbon to the earth and we are disturbing the carbon cycle. So, that means the issue number 2 in terms of carbon emission, that is the environmental sustainability. If we want to sustain the environment for the long years for the future generation to come, then we have to think how to use the fossil fuel so that environment remains sustainable. Issue number 3. So, the issue which is coming or which is arising out of carbon emission is the environment sustainability. That is a major issue, as you often are hearing in the newspaper, the global warming or I do not know what. Third point that you should think, fossil fuel reserves are limited. You also know, as I said in the lecture, a very large amount of primary energy is imported, that 25% of the energy is imported in the form of oil. What does it mean? We have to ensure energy security. We have to ensure energy security. Energy security and environment sustainability are the important issues, and they can be achieved by applying the concept of switch, capture and reduce. So, the concept of environment sustainability and energy security can be achieved by switch. Switch means wherever you are using fossil fuel as the energy source, either for direct energy source, for example, generation of thermal energy, or using for reduction purposes, because it has a carbon and hydrogen, it can do the reduction part also. If it is possible to replace a portion or the entire part of it with the fuel which is renewable, that is called switching. Another important concept is capture. As I have said, it is in the inherent way of deriving thermal energy from the fossil fuel, that is by way of combustion, and the combustion products exits the furnace or wherever the thermal energy is being derived at the temperature of the sink. A large amount of heat is going to waste. Invoke the possibility of capturing the heat and recycle and do whatever you like. Third concept is reduce. If you can reduce it, for example, today you are using 100 kg of carbon, by developing the technology or by optimum utilization, can you reduce to 80 kg or can you reduce to 70 kg, and this reduction brings the concept of energy efficiency. The concept of energy efficiency. Capture brings the concept of energy recovery. Energy recovery and reuse, and switching, it rather allows you to innovate, to think what portion of the energy uses can be replaced by the so called renewable energy. That means that switching mode should have a energy which does not contain carbon. Now, if I give you a simple example, say for example of an iron and steel industry, say India has produced around 50 million tons of steel, 50 million tons of steel in the year 2006-2007. 40% of steel is being produced by blast furnace and basic oxygen furnace route, that means 20 million tons. Now 1000 kg of hot metal will yield around 750 kg of steel because of losses of iron slag. 20 million tons of steel would require 27 million tons of hot metal. 1 ton of hot metal required 600 kg of coke. The 1 ton of coal, it yields 750 kg of coke. That means 1 ton of coal, that means 1 ton of coal will produce around 1.25 tons of hot metal. So, if we need around 27 million tons of hot metal, we need around 27 million tons of hot metal, then we will be consuming around 20 to 21 million tons of coal, to 20 to 21 million tons of coal of coking quality, of the best quality of the coal. So, what I mean to say with this is that there is a large consumption of coal, and it is here, if some technological innovations are being made to cut down this consumption, then it is be beneficial not only from the energy security point of view, but also from environment sustainability point of view. Now, similarly, another carbon emission industry is that of the cement. A very large amount of fuel is being used. So, here a switching, for example, as the cement industry is doing by the use of tires, they contain very large amount of energy. So, in sum and substance, what I want to say is that these switching, reduce and capture will be the basis of further development of the lectures. Now, the course content in fact essentially comprises of the basic application of the above concepts, the switch, reduction and capture, in particular to furnace industries and in general to other industries also. Now, to end the lecture, I would like to give you few self assessment questions. So, here I am giving you few questions which is based on this lecture. First question, what is the difference, say what is the difference between non-renewable non-renewable and renewable energy resources. Energy resources, this I had already explained to you in terms of the lifespan. One is termed non-renewable, another is renewable, because renewable energy is obtained always, whereas non-renewable it takes millions of years in order a energy resource can form. Now, explain with examples. Explain with examples. So, here try to give the example of the non-renewable as well as renewable energy resources. If it is possible, you can give the deposits, then it is very good. Second question is that discuss the energy consumption, discuss the energy consumption in various industries. Now, here you can choose the year of your choice. Choose the year of your choice. You may choose 2007 or 2008. It is just to generate a feeling in you that there are energy consuming industries and hence about the energy reserves. Third, discuss the energy production pattern, discuss the energy production pattern in India for any year of your choice. Here get a feel that the biggest source of energy production, they are the fossil fuel, try to know their percentage and so on. Then what are the issues? What are the issues in using fossil fuel energy? Here you have to discuss how in fact energy is obtained. Now, the last question is, say you are being asked, to reduce the effects of fossil fuel research, of fossil fuel usage on energy security and environmental sustainability, and environmental sustainability. How will you plan, or how will you plan your strategy? That is, I mean here you are required to reduce the fossil fuel consumption. How will you do it? I can give you the hint, as I said, the three approaches: capture, reduce and switching. You can also give an example of iron and steel industry, which uses a large amount of coal, also cement industry which also uses large amount of coal, and develop your answer. Now, as such, after having a feeling of the energy resources and the problems associated with that, we will proceed in the next lecture about the characterization of fossil fuel, and we will now limit to the application of the concept of switching, reduce and capture to the furnace industries in particular, where these concepts can also be equally applied to other industries also.